Hey guys, my name is Joe, and today I wanted to talk to you guys about upgrading our standard stream gauge data collection platform system. We're going to be upgrading the Sunsaver solar controller to the Victron 7515 smart controller, and I wanted to provide you guys a little bit of overview of why we're doing so and some of the benefits that we're going to see at our stream gauging stations. The difference between these two solar controllers is that this solar controller doesn't have the ability to analyze the battery's metrics. So rather than looking at the battery and seeing that it's really low and needs to be fully charged, it can't just take all the power provided by the solar panels and input it into the battery. It rather just pulses a voltage to the battery constantly, no matter what the state of the battery is. So that is the big difference between the smart controller and the non-smart Sunsaver controller. All right, so now I wanted to go over best practices in how to remove this solar controller, because you are working with live electricity, and safely install the Victron 7515. So with that being said, let's get started. As with all visits to stream gauge sites in the USGS, the first thing you're going to do is open up SVMAC and take your initial sensor inspection readings. After you get those sensor inspection readings, be sure to save that file, and then you can begin the process of starting to take apart the solar power. First thing I like to do is remove the look at the time. If you're between 15-minute punches, that's perfect. If you're right at right around right before a 15-minute punch, I would wait and get your last data point before removing the data card. So first thing I like to do is go ahead and inject the data card and take that out of there, so you have that for your records, and there's not going to be any corruption of that file if something does go wrong. Now, most of our stations around the Delta are all different. No one station, for the most part, is identical. Besides this board setup, this is the most identical thing we have out there. But you could have one solar panel, two solar panels, three solar panels. Each site is different, so you're gonna want to know what you're working with before you go there. All right, now that you have your SV mobile file all filled out and saved, you have your data card removed. The next step is to go ahead and start removing your solar energy from the system. So go ahead, and you're gonna have to probably get up onto the station and remove some of the zip ties that are coming down the post and into the bottom of the gauge. Just want to loosen it up so you have a little bit of room to work with the wires. So first step is to go ahead and take a Phillips screwdriver and remove from the solar the ground wire first, okay? So go ahead, and you're going to want to remove the ground wire. And as a best practice here, I should say, is to always tape off all your wires, whether they're positive or negative. You're just going to want to tape them off just so you don't potentially get any arcing between the wires as you're working with them. So I'm going to take a second, put a little tape around this ground wire from the solar, and I'll be right back. All right, now that I've got the ground removed from the solar, I'm going to go ahead and remove the positive. One of the reasons we always want to remove the negative wire first is because if we remove the positive wire while the negative wire was still in place, if that positive wire struck along anything metal in the box, it's a grounded circuit, so you could really get some good sparks. You could damage some instruments. So that's why you always want to unground first and then remove the power. All right, so now I'm going to remove the power lead, the positive lead on the solar. Being careful not to cross it with other wires. And then, just like before we did with the negative, the ground side, we'll get some electrical tape and tape it off. Okay. Now, next thing you want to do is go ahead and remove the ground from the load side. So we're going to move the ground okay, and just like before, we're going to tape it off. Okay, then go ahead and remove the positive lead on the load. Now in these cases there are two leads. We have one going over to the Crydon, and we have the other going up to the Arduino. So we're going to want to tape those off. And it's fine, you can tape these together. If you want to tape them separately, by all means you can, but there is no power here anymore. So you can just tape those together and know that they both go back into the load when you do hook it back up to your Victron. Okay, now the last thing you're going to do is go ahead and remove the negative battery terminal. Now this is coming from your bridle, right, that goes down to your battery. So we're going to remove the negative battery terminal on the bridle, tape it off. Okay, and then now we're going to remove the positive lead from the bridle and tape that off as well. Okay, now we have all of our wires removed from the Sunsaver. We're safe to go ahead and uninstall the Sunsaver. Okay, so now that we've got all of our power removed, we're ready to go ahead and start installing our Victron. First thing you're going to want to do is go to your supply kit, and earlier in the video I put a bunch of pictures of the things that you need to bring out with you, and there's the table at the warehouse that has everything laid out for you. So a couple of things you're going to need right here are your screw kit, your mounting block, and a drill. So let's go ahead first thing and install the mounting block. So in your kit here, you've got some 1 1/4 drywall screws. So we're going to start with that. Doesn't have to be perfect in here, but get your block, line it up in here as best as you can. And you're going to want to put a couple screws, one on each side, and you want to countersink them. So and go in as far as you can. And at least get one more screw in. Okay, make sure it's nice and secure. We're good. Now the reason for this mounting block is that when you come through with your bridle and your other wires, if you have the controller mounted just flush to the board, it's a real tight turn for those wires to get up into the controller. So we're going to use the mounting block to give you a little bit more of access to the port terminals here when you're making the turn from the back and into the controller. So now we will mount the controller itself, and in this kit again you have some smaller screws here, and we're going to want to change tips. So included also are these tips, just because some of these screwdrivers they don't have the ability to get in here because of this little divot. You want to get in there nice and flush. So these are going to enable that. So we'll change our chuck here, load this up, and now we got that locked in. And we'll take some of these provided screws and go ahead and screw these in. This doesn't have to be perfectly level, but you know, do your best to make it as best you can by eye. So get one in nice and tight. Now here's where you can adjust it. So if you put it in, it's like this, doesn't matter. So right now you can kind of get on there, make sure it looks nice and level, and then put your second screw in. I usually go for the bottom corner. And you don't have to wrench these down. You just get them nice and snug. You don't want to tighten it so much that you're going to break the body of the controller. So be mindful of it when you're attaching it. That's all you need. All right. And get the final screw in here. All right. So now we've got our new controller mounted. The next thing is to make a pigtail. So oftentimes we have multiple solar panels at our stations, and so each solar panel needs to be connected up to the controller, and the ports on here are not very big to accommodate all these wires being shoved in them. So for that reason, we're going to create a pigtail, and on the bench in the workhouse you'll find some 4-foot strips of 10-aught wire. So 10-aught wire is going to be plenty big to be able to handle any capacity that's coming from our solar panels that we have out in our station, even into the future if we do need to add and expand panel capacity out there. This is plenty of gauge to be able to handle that power. So 10-aught wire is what we're going to use. Another thing, this is our new bridle we're going to use, and we're going away from those old 16 gauge wires with those clip connect orange USGS HIF made connectors. So we're going to start using these, which are XT90s, and we're also upping the gauge of our bridle and our battery leads to 14-ah. So going to be able to handle a little bit more power with our new wiring system, and then also have a better connection with our battery bridle and leads. So here's our bridle and your leads. All your leads on your battery are going to be male, and all your bridles are going to be female. At your station, you're going to have existing batteries, and those batteries are going to have the old style terminals. So one thing you're also going to want to do is remove those terminals and replace it with these. These are all soldered up and ready to go. The XT90 connection on this end will hook up to your new bridle that you'll also be installing as well. So now we're going to need a pigtail. Like I was saying, we have multiple solar panels, so we're going to have multiple hots and multiple grounds coming in. And so to fit it all in the terminal, we're going to use this 10-aught wire, and we're going to make a pigtail for each the positive and negative. So for this, you're going to want to have a set of good strippers with you. You're going to need these. If you don't have any strippers, you could use a utility knife or something to cut the sheath on this, and then remove the sheath and to be able to splice these together. So for this, I'm going to use the 10-ah, and you want to reveal a decent amount of copper, about that much. And the reason is because you want enough copper exposed to be able to use these waterproof wire fittings to pigtail them together. So now, since I'm working in my garage and I don't have a solar panel set up, we're going to have to do some imagineering here. So for that, we have this little setup here. So imagine this setup, each one of these being two different solar panels. So we have one solar panel here, the positive and the negative, and we have the other solar panel here, the positive and negative wires. Now, they were up into the gauge house and to the bottom, but you've since removed them. You don't actually necessarily need to remove those wires. So these wires could be still in the gauge house. As long as you have enough slack to be able to pull them out to work with in front of you, you'll be good. So what it means to pigtail is you're going to take both the positive leads. You're going to remove the tape that we applied earlier, and then you're going to use this applied 10-aught wire, and they're all black. And so what you want to do is take some red tape that's also on the a red electrical tape that's on the warehouse bench. So you're going to want to take some of this with you. You're going to phase tape it, right, to indicate that this is your power leg. So just go ahead and put a little red tape on the end, and you're going to remove the sheath about, I'd say probably about 3/4 of an inch would work pretty well. Okay, and now you got the 3/4 removed. You're going to go take your two power leads from your two solar panels that are up there, join it with your 10-aught wire that you've phase taped as your power. Take your waterproof wire nut. Now you're going to want to be inside the gauge house when you make this connection. So once you have all these three, you're going to kind of squish them together. Take your waterproof wire nut, stick it on there, and twist till it gets nice and tight. Now there is some dielectric grease within these wire nuts, so you might see that get out the bottom, so, and get all over your hands. So good thing to have like a rag or something with you to wipe off your hands or wipe off the wires if a bunch of the dielectric grease comes out of here. Okay, so right now I have, so now this is the pigtail. Now this is the one that's gonna run up behind here and plug into the PV port. All right, so this is the positive leg, so it's gonna plug into the PV, the photovoltaic positive port on your Victron controller. So I'll set that aside for now, and I'll go ahead and get the other lead, the other leads connected to the pigtail. So I'll remove the electrical tape that's covering the leads. I'll grab my other 10-aught wire. So these 10-aught wire pieces will be cut to 4 foot long, and that should be plenty of length to be able to get from the bottom where these wire nuts are going to reside, the bottom, like right or left side of the gauge, depending on your setup at your station and where the power comes into your gauge box. So we'll now attach the ground lead. So the 2 wires coming down with each solar panel, each negative wire from the solar panels, get those together with our pigtail. Grab another wire nut, twist it on until it's nice and tight. Okay. So now here's our connections. We've got 2 solar panels. So we got 2 positive leads coming down, 1 from each panel, 2 negative leads, 1 from each panel, and we've pigtailed in a 10-aught positive lead and a 10-aught negative lead. And so these 2 are going to be the ones that run up the back of the board and come out through this hole and plug into your controller. So I am going to fish these back behind the board. Reach back here. Fish these through. Okay. Now, you can see a problem here. I have 2 wires, they're both black, and I have no idea at this point which one is positive and which one is negative. Now, an easy way to tell which one is positive and which one is negative is either to undo it and see which wire has the red phase tape down here or that's connecting with the positive leads coming from the solar panel. You could trace it that way. Another quick way is if you had these stripped, you could go ahead and touch the copper here and touch the copper here. And if the voltage read negative 14.5 or whatever number it is, whatever amount of voltage being generated by the solar panel at that point in time, if it's a negative number, you'll know that the red lead from your multimeter is actually on the negative wire. So if you switch the lead like this, and you put the red lead from your multimeter on the other wire, it should read positive. And if it's reading positive, then you know that this red lead from the multimeter, that this line here is your positive lead from the solar panel. So keep that in mind. If you do lose track, that's one way to figure out. Use your multimeter, put your leads on each wire. If it's negative, then you know that you have it opposite. You need to switch the wires. Okay? So that's one way to make it easy. So once you identify which one is the positive wire, go ahead and make sure to put some phasing tape on it. Okay? We don't want someone else to come behind us and not know by just looking at it that, hey, that is the positive wire. If they have to undo it for anything, you just want to make it easy as possible for yourself in the future or other people behind you that are going to have to come work on this station eventually. All right, so now that we've got our solar panel wires run, we've got the wires phased, we need to strip the wires back. We have our new bridle installed here that is hanging down and going to be able to attach to our new battery leads. And then we have our load, which is here's our hot and here's our ground. And so we're ready to hook this up. And so the best practice here to hook this up is to go ahead and hook up your load first. First thing we're going to want to do is grab your positive wires. So these are coming from the F1 and F2 fuse positions here. And we're going to undo these. And be mindful at this point, there is no power here. And they're going to go into the positive side of the load. So that's the furthest port here. Make sure it's backed all the way out. Get them nice and lined up. If these are too long, if there's really long exposed wire here, cut it back and make it shorter, because you don't want a bunch of extra wire or, you know, exposed wire sticking out below here. It just increases the chance that you could get an arc. So then we'll stick it up in the port. Okay. Tighten it up. All right, now once you're tight, go ahead and give a check on the wires and make sure they are in there firmly. Okay, now we'll use the negative. So negative goes right next to it. It's going from our G0 port, and it's labeled on most boards right back over here and into the load ground. Now just be careful when you're working with these wires that none of the wires are intersecting. You just don't want to cause any arcing. That's why all the wires at this point that are still remaining here should have tape on them. I usually don't remove the tape on the ends of them until I'm ready to hook them up. All right. Okay, so now we've got our load hooked up. We're going to want to hook up our battery side. So I've stripped the wire off I've stripped the sheath off the positive, and now I got to strip the negative. Okay. And again, always best practice, go ahead and hook up your positive lead first. So that's the far left terminal here. So this is where this little mounting block is paying dividends, because making this turn would be a lot more difficult without it. All right, now hook up the positive battery lead. Tighten it down. And then your negative ground. And it slips right in there. Okay, so now we've got a connection at our battery and our load, and the last connection to make is your PV, or your photovoltaic, so your solar panels. Okay, so now once your load and your batteries are connected, you should start to see a light on your Arduino, so that is normal. So the last thing to hook up per manufacturer recommendations, that's the Victron recommendations, you hook up your PV or your solar panel last. So like everything else we've done so far, we're going to use our positive wire, which is right here, and we'll remove our tape, expose the raw wire, and we're going to go into the positive port. Make sure these are all the way open and backed out. Since this is a 10-aught wire, it does fill this port all the way, so you want to make sure it's all the way backed out. Make sure you're going into the right port with the right wire, so positive to positive. And slip it up there just like that. All right, tighten it down, make sure it's in place, give it a little check, and now we'll remove our negative wire and check the port, make sure it's all the way backed out, and then apply it to the negative slot. All right, and tighten it up. Okay, now that you have all your wires in place, you should start to see some lights glow here on your Victron. You'll probably see a blue light immediately, and then that could be followed by a series of yellow or green. And on the front here, it indicates, based on yellow or green, what charging condition it is in. Either it's applying a float, absorption, or a bulk charge. So now that you're all connected, you're gonna make sure all your wires are neat, and you're gonna leave these 2 wire nuts at the bottom of your gauge house where they come in from the outside, tucked away nice and neat. Okay, you can even, if you want, go ahead and use the red tape and tape off the wire nut just to ensure that no moisture is going to get in here and affect the system, affect the electrical. You can just give it a little tape job here, protect the wires. Okay, and then do the same thing on the other side with the ground. So you take your black electrical tape, and tape off your ground wires too. That way no bugs or anything like that can get into these wires or make a nest or whatever. You never know what happens out there. All right, so now here are our leads. We're gonna bury those wires down in the corner, make sure everything looks nice and tight. If you removed any zip ties up the power pole, make sure to return those zip ties and get your loops secured and all the wiring secured to the station so nothing's flopping around or nothing's gonna be in the way to be snagged by a boat or floating debris as it goes by the station. The next thing is to open up the Victron Connect app, which you all should have downloaded by now, and you'll log into the controller, and you'll immediately see what is coming in from the solar panel, what the load is going out to the instruments, and what is going into the battery to charge, what's the demand on the battery. So stay tuned, and I'll show you what that app looks like in just a moment. All right, so open up the Victron Connect app, and then you'll see the smart controller appear. Click on that, and it takes a couple seconds to load via Bluetooth. Go ahead and click on that settings cog up in the upper right. Here I'm showing the pin code that's already put in all of the controllers that are on the supply table. It's 264000 for all of them. And then within the settings tab, you're going to hit product info and then hit the edit under custom name. And so what I'm doing that I think makes sense is, like, for a custom name, for example, for Jersey, it would be SJJ-11337190. So that's what I recommend all of you do when you put these in, is make the controller identifiable to that station. After that, we're going to load up the charge settings. So you hit that down arrow there, and then we're going to load up the lead acid battery settings file, which I can send to everyone. But all of the controllers that are on the supply table have already had this done, so you're not going to have to do the pin code or upload the battery chemistry settings. This is what it looks like, so it updates all these settings. You can check them there, and then you always want to check to make sure that under load output, it's selected to always on. After that, we'll go back out to the home screen, and you can see just a generic shot of the home screen and what it looks like. In a moment here, we'll go over to a couple screenshots that I have that highlight some more information that's going on. So a site that's actually in action, so you can discern what's going on. Okay, so at Jersey, you can see we are generating 75 watts from the solar panel. We're reading 17.75 volts and generating 4.2 amps. Also, the battery is reading 1395, so nice and topped off. It's only putting out 0.2 amps, and it's in an absorption state of charge. Here's a little bit more information. Here's False River. So the solar panel is generating 15 watts, and its voltage is 23.51, 0.6 amps, battery 14.4, current 0.3, and it's also an absorption state. On the load side, you can see the load's on. It's only putting out 0.7 amps, and all the instruments are only demanding 10 watts. So 10 watts and 0.7 amps between all the instruments running at false at this point in time. Okay, next we have probably what I think is one of the coolest features of this app. So you can see the max and min battery voltage each day. You can see the consumption in watt hours each day, which I think is really cool. And then also you can see some of the solar panel statistics. You can see the amount of max watts you generated and the max voltage you generated, and it'll give you a total yield of watt hours generated per day. So I think that's really cool. And here you can really see the differences between a really sunny day and a really cloudy day. Now, if you were to click on any of these bars, you can see that they opened up and they show you the exact amount of time that the batteries were in bulk charge, absorption charge, and in float charge. So you can see when the batteries get kicked on, you know, after the sun rises and the solar panels hitting them with energy, it took this particular battery 6 hours and 4 minutes to kind of get back up to fully charged. So that's a pretty good way to look at these. Anyways, I want to thank you all for watching and tuning in. If you guys have any questions, please feel free to hit me up anytime, any place, anywhere. I'll be there. So thanks again, and we'll catch up with you soon.